So we're going to figure out the domain and range of some of these absolute value graphs. So here's number 3, for example, from this worksheet. Do you remember what domain represents?
X's.
All the x's. Notice how each of these branches ends with an arrow, which means that they keep on going forever and ever and ever and ever and ever. So eventually, excuse me, every x value is going to be covered, right? So what would I say for my domain? All reals, yeah. Every single x number, all numbers on the x-axis will get covered eventually. Range, remember, is your y values. Will I get every y value in the whole wide world? No, I will not. I'm never going to get the ones down here. The lowest I ever get is this point, and then it continues up forever in both directions. So I will never get a y value of -5. I'll never get a y value of -6. I'll never get a y value of -100. So what y values will I get, Maddie? Greater than or equal to -4. Yep. So -4 is the lowest I'll ever get, but I'll get every y value above that, because these are going to continue going up forever. So I'll get all the positive y values eventually, but I'm never going to get these ones that are lower than -4. Okay, does that make sense? So try the same thing with number 5. What would your domain be? Still all reals. They continue forever in both directions, but what's your range this time? Yeah, it's got to be greater than or equal to 0. 0 is the lowest y value I ever get. I'll never get a negative y value. And try 6. Domain. What's my all reals, right? If these continue forever, it's going to cover all the x values. But the range would be, oops. Correct. Do you notice some relationship? Well, tell me what you notice about the domain. It's always all real numbers. For an absolute value graph, it's always all real numbers. Do you notice something about the range and the original equation, perhaps? Look at the 3 we did. This one has y is greater than or equal to 4. The what? Yes, it's always the same as k. K is your number on the outside. It's going to be greater than or less than depending on which way your v is going. So if the v is up, it would be greater than. But if your v was upside down, so let's backtrack to number 1, for example. The domain is still all reals, but the range, the y values I get here, the highest I'm ever going to get is 0. So I'll get all the ones lower than that. So I would have the y's that are less than or equal to 0 in my range. But notice that number is always whatever k is. So k was 0, so is that number. K was -4, so is that number. K was 0, so is that number. 4, so is that number. So domain, all reals, range is always greater than or less than whatever k is. Make sense? Yeah? Okay. Ready for the hard graphs? Yes, you are. Or maybe not. Does anyone have any questions on the easy graphs? Then I guess you are. All right. So we take a look at the hard graphs. You can already do the first bunch of them, so we've already talked about it. The first 4 you can do, right? So let's do the first one together. Where would its vertex be? 0, 4, so I put a dot there. And then the only thing that's different about this one, on the other sheet, your slope is always 1 or -1. Here, okay, now the slope is a -3. That's the only thing that's different. So remember, A tells you the slope of the right-hand branch. So on the right-hand branch, I'm going to go follow a slope of 3. Down 3 over 1, down 3 over 1. And then I just do the opposite on the left branch to make it symmetrical, so I'll go down 3, back 1, down 3, back 1. What did changing the value of A do to the graph? What is making A negative do to the graph? You're right, the value of the graph is going to change the width. So if you have a positive A value, your V is going to be upright. If A is negative, what's going to happen? It's upside down. Now, so that's what the sign of A tells you, if it's going to be right side up or upside down. After that, it's really just the number we're thinking about. So in other words, the absolute value of A. So in this case, the absolute value of A is 3. And what did it do to my graph? It made it more narrow than it usually is, right? If you compare it to your other graphs where A was 1, this graph is certainly more narrow. So what would you expect if A had been 5? What would it have looked like? Even more narrow than that one. So the bigger A is, the more narrow your graph gets. Because think about it, it's a steeper slope. So how would I get a graph that's wider than this one?
Fraction.
Yes, if A were a fraction, like a half or a third, some fraction that was less than 1, that would get me a wider V shape. Oh, you guys are so good. Okay, so there's that one. Okay, let's go ahead and we'll finish 2, 3, and 4. Those ones you should be okay to do. And then we'll talk about the rest of them in a minute.